An exponential function is a function that has the form y equals ab to the power of x when a is not zero and b is a positive real number greater than 1. An exponential function is an exponential growth function where a is greater than 0 and b is greater than 1. The variable b stands for the graph's growth factor. The first graph shows the parent function of an exponential growth function, which is f of x equals b to the power of x when b is greater than 1. An exponential function is an exponential decay function when a is greater than 0 and b is between 0 and 1. The variable b stands for the graph's decay factor. This second graph shows the parent function of an exponential decay function, which is f of x equals b to the power of x when b is between 0 and 1. The formula for compound interest is a equals p times the quantity 1 plus r over n to the power of n, t, where a is the amount in the account after a certain amount of years, p is the principal or initial amount deposited into an account, r is the annual rate of interest on the account, n is the amount of times the money is compounded per year, and t is the number of years. The natural base e is an irrational number. As x increases, the expression 1 plus 1 over x to the power of x approaches e. Natural base functions take the form of y equals ae to the power of rx. When a is greater than 0 and r is greater than 0, it is an exponential growth function. When a is greater than 0 and r is less than 0, it is an exponential decay function. The formula for continuously compounded interest is a equals pe to the power of rt. The variables were introduced earlier in this lesson. To find the continuously compounded interest, plug in the variables just like when compounding interest. Arithmetic forms of logarithms is log base b equals x and the exponential form is b to the power of x equals y. Common logarithms are logarithms with base 10. Natural logarithms are logarithms with base e. It is denoted by log base e or ln. By the definition of logarithms, the logarithmic function g of x equals log base b of x is the inverse of the exponential function f of x equals b to the power of x. This means that g of f of x equals log base b of b to the power x equals x and f of g of x equals b to the power of log base b of x equals x. Because they are inverse functions, the graphs are reflected over the line y equals x. For horizontal translations, the function f of x minus h is used when h is not equal to 0. When h is less than 0, the graph is shifted left. When h is greater than 0, the graph is shifted right. For vertical translations, the function f of x plus k is used when k is not equal to 0. When k is less than 0, the graph is shifted down. When k is greater than 0, the graph is shifted up. Reflections of the x-axis multiply outputs or y values by -1. Reflections over the y-axis multiply inputs of x values by -1. Horizontal stretches and shrinks multiply inputs by the variable a, which stretches or shrinks the graph by a factor of 1 over a. The function of a horizontal stretch or shrink is y equals f of a times x. When a is between 0 and 1, it is a horizontal stretch, which only moves it away from the y-axis. If a is greater than 1, it is a horizontal shrink, which moves it toward the y-axis. Vertical stretches and shrinks multiply outputs by the variable a, which stretches or shrinks the graph by a factor of a. If a is greater than 1, then it is a vertical stretch, which moves it away from the x-axis. If a is between 0 and 1, it is a vertical shrink, which moves it towards the x-axis. The product property states that log base b of mn equals log base b of m plus log base b of n. The quotient property states that log base b of m over n equals log base b of m minus log base b of n. The power property states that log base b of m to the nth power equals n times log base b of m. Use these properties to expand or condense expressions. To change logarithmic bases, use the formula log base of c of a equals log base b of a log base b of c. Property of equality for exponential equations states that if b is a positive real number excluding L, then b to the power of x equals b to the power of y only if x equals y. To solve exponential equations, first write the terms so that both sides have the same base or take the log of both sides to get rid of the base. Then use properties from this lesson to solve the rest of the equation. The property of equality for exponential equations states that if b is not 1, and b, x, and y are all positive real numbers, log base b of x equals log base b of y only if x equals y. Using the property listed above, the log being taken away from both sides if they share the same base. You can also use exponentate each side by adding the base of the log to both sides of the equation. For example, if the log has base 2, you can rewrite the entire equation by putting everything as the exponent of base 2. Solve the rest of the equation using properties mentioned earlier. Thank you for watching this tutorial, and we hope you enjoyed it.